Welcome guys to this video on congruent triangles. Now, small note of housekeeping before we get started. The section in the book for this section, Congruent Triangles, is section 4.1. So chapter 4, section 1. The online number is 4.2. So small change in numbering, but just keep in your mind that this is the book, and that online we're going to have section 4.1 because it's the unit 4 online day 2. Yep. But we are going to be talking about congruent triangles, and more specifically what makes two triangles and two shapes really congruent to each other. Here are the list of rules. It's a pretty short list, summed up by the fact that to be congruent you have to be the same shape and the same size. And in order to do that, that means that all corresponding angles and sides need to be congruent. And that's the really big one. The corresponding angles and sides have to be congruent. If you have this, then your two shapes are congruent. If this is off, even by a letter, then your shapes aren't congruent. And because it's so important that corresponding angles and sides are congruent, you have to be careful in how you name them. Which means if I were to draw these two triangles down here, triangle ABC and triangle XYZ, I'm going to make them obtuse triangles. Okay. If I were to name this top one A, B, C, because of my congruency statement, X has to be over here, because that is the corresponding angle to A. So A is congruent to X because these two angles are corresponding, which means that then you have Y and then you have Z over here. So you should always be able to draw the appropriate picture from the statement. And you should be able to tell based off the statement which angles and sides are congruent. So even without my picture, I know that angle A is congruent to angle X, and that angle B is congruent to angle Y based on where they are in my congruency statement. Same thing, angle C is congruent to angle Z. And I can do the same thing with my statements, or with my line segments. So I have AB, line segment AB is congruent to line segment XY. And you can go on down the congruency statement. All of these should match with our picture if we drew it correctly off of the congruency statement. And there you have it, all the congruent angles and side lengths. Alright, now that we've gone over that, let's do a proof. Because what would geometry be without proofs? Now, before you get overwhelmed, as a reminder, this is a flow proof. We've already done one example of this a few videos back. I'm going to bring it back, just kind of review. That way you know what it is. Now, in our proof, we are trying to prove that triangle WXZ, is congruent to YXZ, triangle YXZ. I'm actually going to outline these so that I know exactly what I'm looking at. So here we have WXZ, triangle WXZ, and then we have triangle YXZ. So I need to prove that those two triangles are congruent to each other, which means I need to prove that all the corresponding sides and angles are congruent. So just based off my picture, I need to figure out where are my corresponding angles and what are my corresponding sides. Now when you're doing this, you want to pay attention to the picture and then different key features. So here I have a short side and a short side. Alright, and then I have a long side and a long side. So these are some key features I want to keep in mind as I do my proof and to see if they match up. But before I get too involved in that, let's check out our given and see if that helped us out. So we are given that angle WXZ is congruent to YXZ. So this angle is congruent to that angle. Looks promising so far. We are then told that angle Z or XZW is congruent to XZY. So XZW, this angle right here, is congruent to XZY, this angle right here. Better and better, those are two congruent angles. Finally, we have that WX is congruent to XY. This side to that side. And that WZ is congruent to YZ. This side to this side. So right off the bat, we're given a lot of promising information. And we almost have all 6 pieces that we need. We need 3 congruent angles and 3 congruent sides. Let's go ahead and write these over here in our flow proof. Remember, given information goes to the far left. And we write it like that. Now I actually ran out of boxes, so I put these two in the same box because they're both a given statement, but normally you would have all 4 boxes for all 4 of your given reasons. Okay, let's go back to the proof. Now we need to prove that our last segment is congruent to the other segment and that our 2 angles are congruent to each other. So I'm going to do this in green, that way you know what I'm looking for. So I need to prove that this XY, or XZ, is congruent to this XZ. And that W is congruent to Y. Let's start with XZ and XZ, because that one should appear obvious, because we've done this one so many times. Because XZ overlaps perfectly, and it's in both triangles, we can say that XZ is congruent to XZ because of the reflexive property. And again, the reason why we need to say that XZ is congruent to XC is because it is in 2 different pictures, just like it's in our 2 different statements at the end here. So we need to prove in the beginning that those are going to be the same thing at the end. Now, last but not least, we need to somehow prove that angle W is congruent to angle Y. And if you look back into last class's notes, our theorem is there. The reason for this is the third angle theorem. Now, as a reminder, the third angle theorem states that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles must also be congruent to each other. And that matches this picture exactly. We already have this angle, 1 angle congruent in both triangles, and 2 angles congruent in both triangles. Therefore, we can say that the third angles must be congruent to each other. Okay, and now we have all 6 pieces are congruent, and so we can say that triangle WXZ is congruent to triangle YXZ. Make sure you pay attention to how you're naming your triangles. The letters of the angles need to match up exactly. I will be paying attention to this as we go forward on tests and quizzes, and you will lose points if you've named your triangles incorrectly. Last but not least, our reason for saying that these 2 triangles are congruent are that all corresponding parts are congruent. I can't write down there. There's something in the way on my screen, but there it is. Sign off. And we're done. Always sign off on all of your proofs, even flow proofs. Okay. Go ahead. The video is going to pause. Write your congruency statements for these 2 triangles. Again, you're just writing the congruency statements. So that's a triangle is congruent to a triangle, and whatever the letters are. Pay attention to the order of the letters. Make sure they match up. So for this first one, here's your answer. Now, if the order of your letters isn't exactly the same as mine, that's fine, so long as angle J is in the same position as angle H, and that angle K is in the same position as angle G. Now, the way I do this, my trick to doing this, is I find a landmark, as I call them, so a key feature. In this case, my right angles. I know for a fact my right angles have to be congruent to each other. So that's why I put my right angles first in both of my statements. Then, starting with J, I went up the side that had the 1 congruency mark to K, which went next to my number, or my statement. Then I did the same thing on the other side. Start at the right angle from H, go up the one side marked to G. And then to get my third angle, I went across to G. And the same thing on my second triangle. I go down and across to K. The reason why I do it like this is because when you have pictures where the angles kind of overlap, a very common mistake is to say that angle G is congruent to angle G. And that may not always be the case. So, when you're naming your triangles, find a key feature first in both triangles that you can use as a landmark, and then just follow one angle at a time. That way you have them in the proper order. Video's going to pause again. Do number 11. So for this one, in both triangles, I started with the angle that had the 1 congruency mark. Now you could have started from anywhere. This is just where I chose to start from. Then I went down to the angle that had the 2 congruency marks. So that's from R to T and from J to K. And then from T, you go up to the third one, and then from K, you go down to the third one for L. Make sure your letters match. Last but not least, a few facts to go over and make sure you understand. An acute triangle is never congruent to an obtuse triangle. And the reason should be obvious. If in congruent triangles, corresponding angles have to be congruent, there is zero way an acute angle is ever going to be congruent to an obtuse angle. So these two triangles will never be congruent. Number 2, a right triangle is sometimes congruent to other right triangles. The one we all think of immediately is where we have a right triangle, and then this angle is 45, and then this angle is 45. Okay, this is usually what most people think of right off the bat. The thing to keep in mind is this is not the only variation of a right triangle that exists. You can have a right triangle and this be 30, and then this be 60. This triangle, this 30, 60, 90 triangle, is not congruent to my 45, 45, 90 triangle. So right triangles are only sometimes congruent to each other. Fix my symbols. Okay, these last two. So if triangle ABC is congruent to XYZ, then A is congruent to angle Y. That's not correct because my two angles do not match up in my congruency statement. So this will never be true. Let's go to the next one. AC, so A and C, is congruent to X and Z. Well, that's true because the letter placement is the same, so this would be always. Segment AC is always congruent to XZ. And this is the end of the video. If you have any questions, be sure to ask them in class.